Hi. Lesson 8. Are they similar? Um, Stretched or distorted rectangles. We've talked about distorted rectangles already in the lesson, but we're going to do it today with some graph paper underneath it, which is pretty cool to see. Um, if I look at rectangle ABCD and rectangle EFGH, it looks like this side could be similar to this one. Hold on a second. If I set up a proportion, I could say AD over EH is something, okay, numbers. 3, if I counted the cubes, 3 over 5. And then I could say that BC over FG is also 3 over 5. And that means that, I shouldn't put it in green, that DC over HG should also be 3 over 5, and it's not. And AB over EF should also be 3 over 5. Okay, so the sides are not proportional, because they all have to be proportional. But I can see that angle A, the angles are, because they're all right angles. I could keep going. Angle B, angle F, and angle C, angle G. So the angles are good. The sides are not. And those are the two tests that we've learned about, okay? All right, so faulty logic. Tyler wrote a proof that all rectangles are similar. Make the image Tyler describes in each step in his proof. Which step makes false assumptions and why is it false? All right, so I'm gonna draw over this and it's fine. We're gonna be able to see it. You have paper there that you can draw along with me. So draw two rectangles. Label one A, B, C, D. I don't wonder which one's supposed to be smaller. A, B, C, D. And label the other one P, Q, R, S. I don't know if they're supposed to be different sizes. Uh-oh. My computer locked up. I was taking a little nap while I was fixing itself. P, Q, R, and S. Okay. Translate rectangle ABCD by the directed line segment from A to P. So I'm translating it there. That means that's going to be inside here. A prime and P now coincide. The points coincide because that's how we defined our translation. Yep. Rotate rectangle A prime, B prime, C prime, D prime by angle D prime, A prime, S. D prime, A prime, S. They're on top of each other. So I think that they're already rotated. Segment A double prime, D double prime. So A double prime, D double prime now lie on PS. Yep, so we were good. We drew our rectangles too good, I guess. The rays coincide because that's how we defined our rotation. Dilate rectangle A double prime, B blah, 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 blah. We're going to go green now. Using center A double prime and scale factor PS over AD. So PS over AD. So that PS is bigger than AD, so if I have PS over AD, it's going to be a number bigger than 1, so I'm going to make everything bigger. So I'm going to dilate it, and that's going to make those coincide. Now, if we do the same thing, well, dilate the whole rectangle. I don't know. I don't know about this side. Is that going to be enough? I don't know if I drew my rectangle perfectly, that B triple prime and Q will coincide, or C triple prime and R will coincide. I'm just not sure. So A triple prime, D triple prime, and PS now coincide because those are now triple primes. Yep, because we set it this way, those do now coincide. The segments coincide because A double prime was the center of rotation, so A double prime and P don't move. And since D double prime and S are on the same ray as A double prime, when we dilate D double prime by the right scale factor, it will stay on ray PS, but be the same distance from A double prime as S. So S and D triple prime will coincide, yes, because that's how we defined it. Now, I'm over here. I see red flags on this side. Not sure about that side, so let's read number 5. Because all angles of a rectangle are right, yep, A triple prime B now lies on ray PQ, and it does. This is because the rays are on the same side of PS, yep, and make the same angle. Ours do. We would have had to reflect it if we'd messed that up somehow. So we're good here. Now dilate rectangle all the triple primes using A triple prime and scale factor PQ over AB. So that's where we go. We're going to have PQ over AB. And that's bigger than 1, so that's going to take B triple prime to Q. But the problem is, now we have 4 primes. That's also going to extend this one. All right, so that's our problem. So we sort of had a problem in 4 and 6. All right, due to the symmetry of a rectangle, if 2 rectangles coincide on 2 sides, they must coincide on all sides. No, that's not necessarily true. That could be true for a square, but not a rectangle, because we just proved it over here. When we dilated with step 4, which was our green dilation, not all sides coincided. So then in step 6, our red dilation, we fixed some of it, but then extended the other past, which isn't cool. Okay, so it didn't work. That was our faulty logic. All right, choose one statement from the list, decide if it's true or not. If it's true, write a proof. If it's not, provide a counterexample. All equilateral triangles are similar. Do you guys know the measurement of the angles of an equilateral triangle? When all the sides are congruent, all the angles are congruent. Nope. Not 360. What is the inside of a triangle equal to? 180. So all the angles are equal. Therefore, all equilateral triangles are similar, because even if these are equal to each other, so the sides of the small one are equal to each other, but all the angles are congruent no matter what. So as we dilate it in and out, all the sides of the bigger one are going to dilate together. All the sides of the smaller one are going to dilate together. So there's no, it's all symmetrical and it's similar. All isosceles triangles are similar? Nope. Isosceles, those are equal, but look at this. Okay, I just drew 2 that are not, so there's my counterexample. Oh, we didn't do a proof up there though, did we? There's my counterexample. All right triangles are similar. Okay, there's a right triangle, and There's a right triangle. My counterexample. I try to exaggerate my counterexamples. All circles are similar. That's true. And they gave us this right here. K being your scale factor. The scale factor is just going to be times the radius, and there's no way for me to make a circle that isn't similar to every other circle in the world. Not possible. Okay? All right. So yes, all and all. Definitely not all. Definitely not all. That was fun. Okay? It always makes, like when we get to the end, I'm like, yeah, we got that. We got that. We can learn it. And the lights went off again. Whew.